Hey everybody, this is Larry. This is day 16 of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I am still in Dublin, or at least I'm back in Dublin. I just drove for a long time from Belfast. This is where the intro's from. Yeah, hope you enjoyed that intro. I'm very tired right now. It's about like 1 a.m. with a lot of driving. So hopefully this farm will be okay. Let me know what you think. Okay, today's farm is 1770. Maximum score from performing multiplication operations. Okay, so you're given nums and multipliers and you want to perform exactly m operations. Okay, so those don't match each other, or the size don't matter, don't match, and there's m of them, and we want to perform m of them. So choose on the if operation. You take the beginning or the end. Okay, return the maximum after m operations. Okay, so I think this is probably just gonna be dp is what I'm thinking of. Let's see, m is 10 to the third. So how many? So one thing that you may ask is how many? What's the complexity, right? I think it's very easy to kind of confuse yourself with the complexity for this one. That may be the tricky part. I think this one is pretty okay. So let's go. Yeah, let's do this. I'll show my thought process a little bit more clearly. So definitely, as I write the code, so we'll go over it. Let's kind of write it as. I mean, this is still going to be dynamic programming. We're going to do it top down, just to illustrate. But let's do it as dumb as possible. Say, and of course, I say this with a little bit of a dynamic programming background. So if definitely, if you struggle with this one, try easier dynamic programming problem first. Try to figure out how to not just solve them, but also really get good at explaining and understanding the complexity. That's what I would say first. And this one, I think, has a fun analysis. So let's take a look. So let's just say we have max. Okay, fine. Max score. We have left. We have right. You know, just to show how many things we used, and then m index, right, for the index for multiplier. Okay. And then okay, so I mean, we write it like I said, we write it as naively as possible. Let's see. I just want to make sure that m is smaller than n. I thought I read that, but wasn't sure. So basically, we take the beginning and the end, right? So basically, yeah. So if m index is equal to m, then we return 0, right? We ran out of m's. Otherwise, we have two max scores we can do, right? We have left plus 1 right, and we don't have to worry about checking for stuff because it won't go over, right? That's the idea. And this is the other one. And if we choose the left, we add the score of num sub left times m index. Is not true, obviously. And then the other one is num sub right times multiplier. Multiplier is m index, right? So this is left score. If we take it from left, this is right score, and then we turn max of left score, right score. And I think that should be good. So then we set it up by, you know, just do it 0, right? Let's run it real quick, right? So this looks good, just to make sure I didn't have any typos or anything silly. I've been doing that a lot lately, so don't, so let's not assume that, you know, that was going to be good. Okay, so let's just create a little bit more. This should time out because we haven't memorized. Okay. I mean, this should time out, so it seems like my theory is correct. And the reason is because now it does like this 2 to the end thing, and it reuses a lot of things, right? So let's do a time complexity really quickly. Let's say that we know how to memorize, and we do a time complexity, right? What are we doing? Well, left, the way that we usually say it is, okay, left can be 0 to n, right can be 0 to n, m index could obviously be 0 to m. So and time complexity is going to be equal to, or total time, maybe total time complexity is equal to time per input times number of inputs, right? You could do unit analysis there and check out. And of course, if you say time per input is going to be O of 1, just because, that's where we memorize these are all O of 1 operations. And then number of inputs is equal to O of n squared times m. That's from, these n and m. And then you go, okay, well, if I did it this way, clearly this is 10 to the 5th times 10 to the 5th times 10 to the 3rd, and that's no bueno, right? So that's first thing. Man, I'm just wondering whether I got it wrong, because that would be funny if that was the case. Should be okay, but yeah, should be okay. Okay. Well, the first thing to kind of reanalyze this. Sorry, I just want to make sure in my head a little bit, because that would be really sad if I explained the wrong solution for like 10 minutes and then I'll be like, oh wait, I missed something. Well, the first thing to notice is that left doesn't go all the way to n, right? If n has way too many numbers, it doesn't matter because it's bounded by m. So same logic here, and we can reduce this to m cubed, right? If let's say we do it to this, right? The second thing to kind of recognize is that even though this has three inputs, what is happening there, right? One way that you can, mathematically see this is that, left plus right is equal to n or something like this, which is, like we said, is bounded by m. So let's just say left plus right is equal to m, right? Then now, well, then what does that mean? Well, left plus right doesn't equal to m per se, but it will start off that way. And then how do I say this? Sorry, I know what I'm. Oh, I think I do. Maybe I'm wrong, but I'm trying to kind of find the way to explain it in a understandable way. And maybe that's another way. But well, the full formula, I guess maybe we can think about it this way. The full formula is that let's say we use m indexed, right? So m index is, let's say numbers used is equal to m index plus 1, say, right? Or maybe just m index, actually. Yeah, right? And also left plus let's just say m minus right, because we can throw away the middle numbers, which is another way of saying it, so that now we're bound. Left plus m minus right is also equals to number used, right? So here, maybe I could write it in a clearer way, right? So numbers used is equal to m index. Numbers used is also left plus this thing. So, why not set it to each other, right? And that's pretty much the idea for this one. And as you can see, you could do some mathematical things. So m, we move m to right? And then now we minus m left on the whatever side, and now we have this formula. What does this mean, right? Well, that means that, we know what m is. M doesn't change. So given two of these variables, we know the other one. That's the basic idea that I'm trying to prove here, right? If we know any two variables, then we can find the other number. So that means that now, instead of m cubed, the number of inputs is equal to m squared. And now 10 to the third square is just 10 to the 6th, which is a million. So that's basically the idea on how to get this to work. Also, again, Python maybe too slow, we'll see, but that's basically the idea. Yeah, so let's kind of figure that out. And now let's just say we keep track of left and m index just because they're easier to use. So then now we have is cache is equal to or has cache times m plus 1 for m plus 1. And then cache is just equal to, I don't know, none, right? Just set it. Let's get rid of this so that it's easier to use. I'll just put on the bottom, so at least if you could look at it if you really like. But yeah, okay. Yeah. So then now it's just about the caching, and then now if has cache left, and again left cannot be greater than m just because you can use more than that, right? So we don't have to worry about. Hopefully we don't have to worry about our bounds. I might have off by ones. Pretty bad about those. But anyway, if it has cache, then we return has cache left m index. Otherwise, has cache left m index is equal to true. Also, this is I got it wrong. You have to return the cache, not the hash cache, obviously. And then now cache of left m index is equal to this thing. And then we just return the cache. Hopefully this is fast enough. Well, this is fast enough for the test input anyway. See, much faster. I wonder, because a million is always a little bit sketch on Leetcode, to be honest, in Python, especially memorization. We will see. Let's give it a quick submit. Oh, wow. Last time I did this, it was very slow. So we'll see if this is time limited. It might be that Leetcode is silly and make us time limited anyway. But this is generally the idea, and it should be, in theory, good, but we might get time limited because Leetcode is silly. Okay, fine. 30, so that's not even close. I mean, I think I could write it top down, but still, that's a little bit sad. What did I do last time? Yeah, I wrote it top down. Huh. And it still took 9 seconds, huh? Is there a better way? This is such a Leetcode silliness. This is such a Leetcode silliness because a million should obviously be fast enough, but yeah, maybe that's why there's so many downloads. Not quite. I mean, I could write it bottoms up. I don't know if we're learning anything per se at that point. I'm just curious. And that's why I have like so many wrong answers. It took me 40 minutes to because I was trying to convert it to C++. Let me see what I did. Maybe I had a typo here. That doesn't seem wrong. Seems mostly right. I mean, it seems very similar to what I did, but I guess after I fixed whatever it was, I have a time limited anyway. At about the same number of test cases. That's really silly. I don't know what to say. Well, I would say I mean, if you've gone this far, give yourself a pat on the back. You've done mostly good enough, if you ask me. But let's see what is going on here. I mean, I don't know what to say. There's some typos, but and yeah, I mean, I was wondering whether I did some other things that made it fast enough, but Yeah, I don't know. I'm trying to think whether there's a better than m squared solution, but I really don't know that there is or isn't. Um, well, friends, uh, maybe this is why there's so many downloads. It is very tiring. Okay. Well, I would say hopefully the explanation was good. I don't even know if this passes anymore, to be honest. So I don't even know. Let's see. I don't know. They did reduce the number of tests, but 30 out of 50. I'll try to. Okay. Well, I guess if there are fewer test cases, maybe they made it a little bit better. There's 60 last time, though 36 out of. I don't know. All right. Let's convert this to bottoms up, and then I don't know. I mean, I already did it in the past a year ago, but these things are always good to practice. Let's see. The hard part about bottom up conversion is just about it's about making sure that you do it in the right order. So we'll see if we can do in the right order. So let's see. Let's just say I in range of m maybe, and then here also m or m plus no just m. Okay, and then right is equal to, as we said, what did we say? Right is equal to m plus left minus m index, which is I. Let's actually, for consistency sake, let's call it m index. Hopefully this is right. I don't remember this is an off by one from here. What did I say? Is this right? I'm just looking here. M minus, no, this is this minus 1. So okay, I mean this was roughly right for big O, but yeah, so this is this plus 1, so right is going to be this minus 1. Okay, hopefully this is right, we'll see. And then now dp of left m index, right, is equal to max of dp left plus 1. Well, this was going the other way, so oops. I guess we don't need the right. Oh, I guess we do need the right to make it easier to. I mean, we'll clean this up in a little bit, because we're doing it the other direction, which is a little bit awkward for sure, or at least not right. Okay, right. So that means that this plus 1. Okay, so we actually want to start at 1 1 maybe. And then going the other way is so much easier though. Yeah, maybe let's just do it this way then. Then here in that case we will go from let's see. Maybe not. Let me think about this. So okay, so m index, this is the previous row, so we can just say let's say minus 1, right? So it's equal to these, And then, is that even right? I don't know. Wait, hang on. This does require, because I did it from the other direction, this requires some little bit of Larry thinking. But this is basically the idea. And then at the very end, we should be able to return TP of, I guess, max of whatever TP of I m for I in range of m, something like that. But we still have to get this formula quite a little bit better. Let's see. What is the base case now? The base case is in the beginning we have nothing, so dp of 0, 0 is nothing, right? Because we've used 0 on the left and a 0 on the m index. Okay, and then now we just have to do it the other way where, okay, this is equal to, so it could have, the last number could have been from the left side, or the last number could have been from the right side. Right, if the last number was the right side and left didn't change, okay, fine. I think this is slightly off. Just gonna run it real quick just to see that I forgot a comma. It's also m minus 1. Let's see. Yeah, the last one was on the right, so then right was already modified, maybe. No, this doesn't go all the way. That doesn't seem right. No, this part's okay, but the right is wrong, isn't it? What is going on here? Let's see. Maybe my formula for the right is a little off by 1. Okay, so left, right, m index. I guess I should put n as well. So also, oh yeah, this has to be from 0. So many silly possible errors. Zero, then right is, so n is 3, so 0 and 2 sounds right. 1 and 3 doesn't sound that right though. 1, 2, right should not be 3. What is wrong with this? Maybe I messed this up. What did I have? Okay, so m plus left minus m index is equal to right, right? Did I mess that up? Maybe I messed it up to begin with. Is that right? M index is 1. No, I guess left can only go up to M index, including M index. Maybe that's why. Okay, this is still wrong. Yeah, I think we can also just translate it in a less, or in a dumber way. Okay, f m index is equal to 0. What was my old code? Well, okay, so we can do something like copy and paste this real quick. Okay, this is equal to 0, then what? dp of m index of left. Well, we haven't used it yet, I guess. So otherwise, -1, I think, +1. dp is equal to max of itself, or I don't know why I did it the other way, actually, now that I think about it. Anyway, plus. Okay, so this is just me pushing then. I always forget. I don't use to push dp very often. It's what people call it these days, right? Well, at least I got one question right. That have a type off by 1. They seem close. Maybe my base case as well. Let's see. Should it be 0? Well, if it's 0, left should be 0. So should be okay. Maybe I need to continue. Oh no, because this is push, so you definitely don't continue. This is off by 1. what I have this, right? So then now we put the +1 on here, +1 on here. So then now it's -1. Now this should be right. Oh. This is, I use M as a proof by bounding it, but the actual thing should be N because it's from the right side. Okay, wow, that was a very silly mistake. We'll see if this is fast enough though. I don't know, because Leetcode clearly is a little bit silly with the test cases. If not, then oh my god. Oh my. 33, wow, that's even worse than before. Sorry, just I'll keep it up. I was just trying to clear my mind. I don't know what to say on this one, other than that Leetcode is again being really silly. Because this is a pretty tight 10 to the 6, right? I don't think I did anything funky. I mean, other than calling max functions, so. What did I do again? Did I do the if thingy check? No, I just did it this way. I mean, yeah, maybe I did this, but I don't think that makes a difference. I thought that they did fewer test cases, but maybe they just made it harder. I mean, we can allocate less memory, but that shouldn't matter that much. And this is me on vacation trying to do a quick one, and Leetcode is just being stupid. Like, check your things, man. Check your code. I mean, I don't know if there's a Python code that works fast enough without like some, like, I don't know, more manipulation. I don't want to spend all day on this. On like things that doesn't matter, right? Like algorithm is the thing that matters, and unless you're doing something really, you know, really whatever, then yeah. Let me actually also. I guess I should have took this case. Well, there's a lot, but. I mean, this, yeah, I mean, look, is it great? No. Is it bad? Also, no. Like I said, there's no way for anyone to know if this is good enough, because this looks pretty good to me. Eight, 2, 3. That was slightly faster. I mean, this is a common trick, but I don't know if this is gonna be fast enough. But I'm gonna YOLO submit, I guess. Probably not, because this only did 33 cases. Oh my. I don't know what to say, friends. Thanks for wasting 25 minutes of my life. I guess that's what I would say. Maybe I could have wanted 90. This should, 5 seconds should not be faster than 96% of code. That is just ridiculous. Maybe I could have changed this as well, but I don't even think. I mean, it gets dominated by these function calls. So I'm just copying pasting to my Discord. Hang on. I have to wake up early, but thanks, Leetcode. All right, that's all I have for this one. I think I did all the explanation already. Maybe not on the bottoms up one, to be honest. But really, I just did the top down and I converted it. I'm really out of energy right now. Thanks, Leetcode, for nothing. Thanks for wasting my time. Thanks for wasting everyone's time. I'm kind of annoyed today. Not gonna lie, just because. I have no words. Anyway, stay good, stay healthy, to good mental health. Hope you have a positive attitude. And like me today, I'm just too tired to deal with this. But I will see you tomorrow. See you soon. Good luck. And I'll see you later. Bye bye.